Hey everybody, this is Mr. Walsh, and I'm going to go over this Lewis dot structure sheet, but I'm going to talk about it not just with Lewis dot structures, but I'm going to talk about geometry here. Okay, so let's draw Lewis dot structures and let's determine the geometry of these compounds. So this particular worksheet is not a worksheet on how to draw Lewis structures, so if you want that, you have to go back maybe even a couple of videos and look, but this is just using Lewis dot structures to then determine the geometry, so hopefully we can get to that, okay, in here. So the Lewis dot structure of CH2F2 looks like this, okay. Okay, C is the central atom, H, 2 H's, 2 F's. Okay, and then when you build this, that's what we're going to do. We get a structure that looks like this. Now, I get that it looks like, you know, you have the H's, which are these white ones here in this case. Okay, looks like the H's aren't across from each other. Okay, it looks like they're 90 degrees. But what I can do is I can do this, and you can see that the H's are across from each other, and the green ones, the F's, are also across from each other. And so this is what this looks like. Okay, it's got 4 bonds. So we built this, okay, we looked at it, and this is a tetrahedron, or tetrahedral, depending on how I taught it in class. Okay, now for CO2, the structure looks like this. Okay, it's got some double bonds in it. Okay, and when we do this, this is what it looks like. Okay, and so even though this is a double bond, it's still just like one place where bonds are. So we're going to still just have this as one place. So there's this. Notice that all these atoms line up. So this is a linear structure. Okay, let me come over here to CCl4. Okay, so CCl4, I built this. Okay, CCl4 looks like this with all these chlorines around it, and each of these chlorines has 6 valence electrons plus the bond, adding up to 8. Okay, around each one. So there's that. And when we have this structure, okay, I built it, and it looks like this. Okay, and notice again, this has 4 bonds to it. Okay, it looks like this, right? If you kind of put it up on its end here. Okay, and so this is called this is still a tetrahedron or tetrahedral. Okay. Okay, so HCN, you've drawn this a couple of times, but if we're going to do this, the C is the central atom, and we got something that looks like this. Okay, so I built that. Okay, and so we have something that looks like this. So we have a triple bond here between the black one and the blue one here, and that triple bond still counts as just one place where electrons are causing a bond. And so that is considered 1 and 2. So there's 2 bonding areas. Okay, and so that means that this thing, and you can see it, that's why I wanted you to build these things. This is a line, so this is linear. Okay, now we have CCl2O, COCl. And the reason why I can draw these Lewis structures pretty quickly is because I've been doing it for so long. Okay, I don't expect you out there to be able to do this so quickly. You have to use the steps, those 5 steps. Okay, and then I built this thing, and this is what it looks like. Notice here, it's pretty accurate. There is a double bond here. Okay, so it's pretty accurate to what this looks like. Okay, so this thing is flat. Okay, it's a single plane, so this is triangular, but when we're talking about three-dimensional things, it's not triangular, it's trigonal, and then planar, because it's flat. Trigonal, triangular, flat. Okay, trigonal, planar. Okay, then the next one is F2. So this one is actually the simplest of them. So with F2, and I built that, we have this. Okay, we just have two atoms. Anytime two atoms bond, no matter how many electrons are in between them, those two atoms form a line. So that is linear. Okay. SiF4, so we'll put Si in the middle, F's around the outside. Then we'll complete the octet with electrons. So I built this, and this one looks like this right here. Okay, so again, this is something with 4 bonding places, and it doesn't look like this when you see it here, but if I put it up, you can see how it's like, looks like a cross, but it's not. It's actually has 3 dimensions, and so this is a tetrahedral shape. Okay. Okay. SO3. S goes in the middle. We put a O, put the extra electrons around it. And again, the reason why I can do this so quickly is that I've been doing this for a long time. So I built this. That's what this looks like. And again, this has 3 places where there's electrons. You can see the double bond here. So it's like these two things are pretty much the same except the atoms that make it up. Okay? So it doesn't even matter what atoms there are. It just matters how many places there are bonds. So notice it's flat. Okay? And it's triangular. So we call that trigonal planar. Okay? And the last one here, SiO2 is going to be Si with double bond on either side. Okay, and I built that. That one looks like this. So that and this look exactly alike, right? Again, it doesn't matter what kind of atoms are in it. It just matters that they're in a line. And so you have a double bond here between the O, double bond here between this O, and you count that as just one place where electrons are for the geometry of this thing. So you can see these 3 atoms are all lined up. So we're going to call this linear. Okay, so there you have it. This is the geometry, Lewis dot structures to get geometry worksheet. And so there you have it. Have a great day, everybody.